Okay, this is a similar figures review. Okay, that you guys are to complete by the day of the test, which is Wednesday, the 20th. Yeah, the 20th. Okay, so question one here. This is going to be a two-part video. Okay, so part one is going to go over the front half of the review. So 1 through 16. Okay, and then I will do a second video for part 2. So what does it mean for two triangles to be similar? Similar triangles are the same size and the different sizes, same shape. So different sizes, same shape. So we have same shape. We have different sizes. Okay. Same shape. So we're going to have 3 pairs of congruent angles. If you have 3 pairs of congruent angles, that means your figures are going to have the same shape, different sizes. So they could be the same size if our scale factor was 1. But the key here is our sides are going to be proportional. 3 sides are proportional. Okay, 3 sides are proportional. What is meant by the similarity ratio? So the similarity ratio tells us how similar the triangles are, how much larger one triangle is than the other. So the similarity ratios describe how much larger one triangle is from another, or how much smaller. So the size difference is really right. They're different sizes. The similarity ratio describes the difference in sizes. Okay, if it's a similarity ratio of 1, then we know the triangles are the same size. So not only are they the same shape, but they would be the same size. Anything less than 1, that second triangle is going to be smaller than the original. Anything larger than 1, that triangle is going to be larger. Right? The scale factor, another name for the similarity is the scale factor. So it's the scale factor. How much are we dilating the other triangle? Right, dilation. How big is the dilation? Okay. Again, I'm trying to use the Epson pen to save on the markers. So the handwriting is worse, but saves money. How can two triangles be proven similar? Well, we can find that all corresponding angles are congruent. And all sides proportional. Okay, that's the definition of our similar triangles. 3 pairs of congruent sides and 3 sides are proportional. Or we have 3 shortcuts. We can use angle similarity, side similarity, or side angle side similarity. Right? Angle similarity, side similarity, or side angle side similarity. Okay, 2 pairs of congruent angles. If we have 2 pairs of congruent angles, corresponding angles that are congruent, then we know the triangles are similar. If we have 3 sides that are proportional, then we know the triangles are similar. If we have 2 sides that are proportional and the included angles are congruent, then the triangles are similar. Yep. It's 1, 2, and 3. So 4, 5, and 6, they want us to determine whether each pair of similar figures is similar. If so, we want to write a similarity statement and a scale factor. So first one, I see information on all the sides, so I'm going to look at, see if we can't show they're similar by side, side, side. Okay, so RJ is the shortest side, and KN is the shortest side. So if we've got to rotate this one about 90 degrees, okay, so 10. So RJ is going to correspond with KN. Okay, and then we're going to have MJ corresponds with PN. And then we have RM corresponds with the largest, right? So KP. Okay, so that's going to be 10 over 15. Again, the two smallest numbers, right? Because if these are going to be proportional, the small sides are going to match up. Okay, and then we have 24 over 36. And then we have 26 over 29. These three ratios are equal. We know the triangles, the three sides will be proportional, and if the three sides are proportional, we know the triangles are similar by side. So this is 2 over 3. This is 2 over 3. And this is also 2 over 3. If you put in your calculator, you get 0.67, 0.67, 0.67. Okay, so we have side, side, side. So it's a yes, they are similar by side, side, side. We want a similarity statement and a scale factor. So our similarity statement, so triangle, we can name this again 6 different ways. Let's just name it RJM. It's similar to triangle. So it corresponds with R. Right, we said it was K. J is going to correspond with N. And M is going to correspond with P. So this is our similarity statement. Our triangle RJM is similar to triangle KNP. The last piece we want is the scale factor. Well, our scale factor, okay, it's going to be 2 over 3 or 3 over 2. Okay, so this triangle is the smaller one. It's 2/3 the size of this one. So 39 times 2/3, 26. 36 times 2/3, 24. 15 times 2/3, 10. Okay, or we could look at it as this triangle is 3/2 bigger, 1.5 times bigger. 10 times 3 over 2 is 15. 26 times 3 over 2 is 39. 24 times 3 over 2 is 36. Okay, so our scale factors tell us how much larger or smaller one triangle is from the other one. Okay. All right, number 6. Number 5. Okay, number 5. So first off, let's try and find what these missing angles are. Okay, so we know the 3 angles of a triangle are going to add up to 180. So 62 plus 60 plus the measure of angle C is going to equal 180. So we're going to have 122 plus the measure of angle C is 180. If we subtract 122 from both sides, we get the measure of angle C is 58. Okay, so we know this one is 58. Okay, over here, same thing. Right, so we can do 180 minus 54 minus 60. We're going to get 66. Okay. So are these two figures similar? The answer is going to be no. They only have one pair of angles that are congruent. Okay. Right. One pair of angles. Angle B is congruent. Angle D. Okay, but that's just one pair. We need a second pair, and we don't have it. This is 62 and 66, 58 and 54. So our answer is no, they are not similar. Explain your reasoning. Only one pair of congruent angles, right? We need at least two. Okay. Only one pair of congruent angles. Okay, number 6 here. Okay, let me clear the board. So, okay, you can pause it if you need to pause it. Go back if you need to go back. Put it on 5 times the speed if you want to hear me talk really fast. All right. Number 6. So RQ is going to correspond with LK, and then QP is going to correspond with KJ. Okay, so that's going to give us 12 over 15 and 9 over 12. Okay, notice we did have 2 angles here. Angle Q was congruent to angle K. So we had one pair of angles. Okay, but here, what are we going to get? Divide by 5, divide by 3, we get 4 over 5. And here we get 3 over 4. So those don't equal each other. So our answer is going to be no. Sides are not proportional. Right, because the ratios are not equal. Proportional. Okay. No, because the sides are not proportional. Okay, our ratios have to equal for the sides to be proportional. Okay, number 7 and 8, state whether the polygons are similar. Okay, state whether the polygons are similar and then give the similarity ratio. Okay, well, for these, we need to show all the angles are congruent and all the sides are proportional. Okay. So we have all our angles. Okay, now we need to look at the sides. Okay, so 5 is going to correspond with 10. 2 is going to correspond with 4. It's between the 1 arc and the 2 arcs. 1 arc and 2 arc. Okay, 3 is between the 3 arcs and the 2 arc. So on this one, between the 3 and the 2 is the 6. Okay, and then 1 and 2. Reduce all these fractions, we get 1/2, 1/2, 1/2, and 1/2. Okay, so all those are equal. So our sides are proportional, our angles are congruent. Since our sides are proportional and our angles are congruent, we know the triangles are similar. So the answer is yes. Okay, give the similarity ratio. Okay, where our similarity ratio is going to be 1/2 or 2 over 1, right? 2. 2 over 1 is just 2. So this quadrilateral is 1/2 the size of this one. 10 times 1/2 is 5. 4 times 1/2 is 2. 6 times 1/2 is 3. 2 times 1/2 is 1. Okay, and then this one, the larger one, is twice as large as the small. So 1 times 2, 3 times 2, 2 times 2, 5 times 2. Okay, the next one. Okay, let's set up our ratios. So we have 6 over 4, 6 over 5. Already we see a problem. Those two are not going to be equal. Okay, 3 over 2 and 9 over 6. Okay, if we reduce, we're going to get 3 halves, 6 over 5, 3 halves, and 3 halves. So 3 of them are 3 halves, okay, but these are not going to equal 6/5. So since all the sides are not, the ratios of the corresponding sides are not equal, the sides are not proportional, so we can say no. These are not similar figures. They're not similar figures because the sides are not proportional. Number 9, solve the proportion. going to solve it over here because, again, I have to write large because the Epson pen is not very precise. Okay, so we want to cross multiply. Okay, so we want to get 6 times 9 on one side. And the other side, we're going to get x plus 3x minus 3. We see this top there. Okay, 6 times 9 is 72. No, it's not. It's 54. Okay, FOIL. So first, outer, inner, last. So x times x is x squared. Negative 3x. X times negative 3 is negative 3x. 3 times x is 3x. Then 3 times negative 3 is negative 9. Okay. Combine like terms, negative 3x and 3x are going to cancel each other out. So we got 54 equals x squared minus 9. We add 9 to both sides. Okay, that's 63 equals x squared. Then we take the square root of both sides. Okay, we're going to get the square root of 63 plus or minus the square root of 63 is going to be equal to x. Okay. Next one, so again, cross multiply. So we're going to get 3y times 5y. Okay, and then we're going to get 10 and 54. Okay, this is going to give us 15 y squared is 540. Divide by 15. We get y squared equals, let's see, 15 into 540. 3 times. It's 45 minus 90. It goes in 6 times there, 36. Take the square root of both sides, we get y equals plus or minus 6. Okay. Okay. Number 11, so that's 9 and 10. So this was 9 and this was 10. Okay. So this was plus or minus square root of 63. Here was x, y equals plus or minus 6. We could plug them in to make sure, but I think we're okay. Okay. Number 11. An architect's model for a building is 2.7 meters long, and so let's make a building. Here is the actual, here's the model. Here's a model building, here's the actual building. Okay, the model is 2.7 meters long and 1.1 meters wide. Okay. The actual building is 360 meters wide. Okay. What is the length? So if we want to switch them, just to make it simpler, let's say, because it's a bit confusing here, 2.7 centimeters long, 2.7 meters long and 1.1 meters wide. The actual building, because we said this was the wide side, so now we're going to say this is 360. How long is it? So length or height is what we're going to call that way. I mean, it really doesn't matter how you do it as long as you are consistent. Let me postpone the update. So as long as you're putting the long side 2.7, you got to match that up with the x, and the wide side you match up with 360, 1.1 and 360. Okay, we got to set up a proportion. So 2.7 over x is going to equal 1.1 over 360. Cross multiply, you get 2.7 times 360 is going to equal 1.1 times x. 2.7 times 360. 2.7 times 360. It's going to be 972. Divide by 1.1. We get 883.636 meters is x. So 883.636 meters. Okay. Just let's plug it back in just to make sure. 2.7 divided by our answer is 0.003056. Then 1.1 divided by 360 is 0.003056. So we know we have the correct answer. The length of the building is 883.636 meters. 12 and 13 want us to find x and y. Okay, so find x and y and z, x, y, and z. X, y, and z. I think x and y are the easiest here. Okay, so 5. So okay, so it's telling us they're similar. So we know AB corresponds with DE and AC corresponds with DF. Okay, so and then BC corresponds with EF. We're getting this from the name. Okay, so we know 5 is going to correspond with 10. Okay, and x is going to correspond with 4. Cross multiply, 5 times 4 equals 10 times x. So 20 equals 10x. Divide by 10, and we get x equals 2. Okay. X equals 2. We can set it up for y as well. So 5 over 10 is going to equal 6 over y. Cross multiply, 5y equals 6 times 10. 5y equals 60. Divide by 5. Y is going to be equal to, 5 goes into 50 10 times. So it's going to be 12. Okay, y equals, y equals 12. Okay. We got to find z. Okay, so what do we know about angles? Corresponding angles are congruent, right? The sides are proportional. That's why we can set up these proportions if they're similar. Okay, the sides are proportional. The angles are congruent. So angle A and angle D are congruent. So if angle D is 50, angle A is also going to be 50. Angle B corresponds with angle E. So if B is 70, E is also 70. Means how do we find Z? These three angles should add up to 180. So 180 minus 70 minus 50, and that's going to be 110 minus 50 is 60. So Z has to be 60 because these three angles have to add up to 180. So Z equals 60 degrees. Okay, number 13, NMQP is similar to SRUT. So again, we can look at the letters here to determine which sides are corresponding. So NM is 18. It's the first two letters. SR is the first two letters. So MN is going to correspond with RT. Okay, so let's just write them up here. MN corresponds with let me do NM. Okay, NM corresponds with SR. R. Okay, MQ. Okay, we're getting this from the name. MQ is going to correspond with, the middle two is going to correspond with RU, QP, and UT. And then the last one is PN and TS. PN and TS. Right, we're getting that all from the name, from the same order. Okay, so we're going to have MN and SR, so that's 18 over 30. And we can set that equal to, what do we have, PN and TS, which is X and 25. Right, these are corresponding sides, so it's going to be X over 25. So we're going to cross multiply. We're going to get 30x. We get 18 times 25. So 18 times 25 is going to be 450, right? Because 25 times 4 is 100. 16 times 25 then is 400, and then you're going to have 50 more, so it's 450. Put in the calculator anyways, and we get 450. Didn't need to though, right? 450. Okay, divide that by 30. Okay, 45 divided by 3 is 15. So I'm looking at 15. Doing the calculator just to make sure, and we get X equals 15. Okay. X is 15. Okay, and then Y is the other one we need to find. So we know 15 is going to correspond with Y, right? QP and TU. So 18, we can use 18 over 30 again. So 18 is the 30, right? 18 is the 30 as 15 is to Y, right? NM over SR equals QP over UT. Okay, cross multiply. 18Y. 15 times 30 is, we just said, 450. Okay, and then divide by 18. And we get Y equals 25. Yes? Is that what we got? Does that make any sense? Yes, it does make a lot of sense, okay? Because if this is 25, well, hold on. We found X to be 15, right? So if this is 15 and the corresponding side is 25, then the corresponding side for this one also has to be 25. Okay, so, right? Corresponding 15 is to 25 as 15 is to 25. Okay, and the last part is Z. Well, we know angle M. Right here, angle M corresponds with angle R. Right, the second letter is up there in each one. So we know that if R is 115, Z is going to be 115, right? Because the measure of angle Z is going to equal the measure of angle R. Right, so we get Z equals 115. Okay. All right. That's 13. So now let's go down to 14. And then we'll finish with this part of the video with 15 and 16. So let's do 14, 15, and 16, then we'll cut it off and do a second part. Okay. Triangle ABC is similar to triangle DFE. Find the measure of angle D and the length of EF. So we want to find the length of EF and we want to find the measure of angle D. So let's find the measure of angle D first because it's easier. We know the three angles of a triangle have to add up to 180. So the measure of angle A plus the measure of angle B plus the measure of angle C have to equal 180. Okay, 120 is going to give us 120. So 180 minus 120 is going to be 60. So we know the measure of angle A equals 60. Well, A and D are corresponding angles. And we know in similar triangles, corresponding angles are congruent. So we know angle A is congruent to angle D. So the measure of angle A is going to equal the measure of angle D. We said the measure of angle A was 60, so we can substitute that in, and we get the measure of angle D to be 60. Okay. This one's 60. So its corresponding angle here is going to be 60. This is 100. This is 20. Okay. Let's call EF X. Put an X there. Okay. We know the triangles are similar, so we know the sides are proportional. Right. So AB is going to correspond with DF. AB and DF. Okay, and then BC is going to correspond with what we call CB. CB is going to correspond with EF. Okay. So that's 3/2 and 9/x. Cross multiply, we get 3x equals 9 times 2. 3x equals 18. Divide by 3. We get x equals 6. X equals 6. So EF is 6. EF equals 6. 3 is to 2 as 9 is to 6, right? 3/2 equals 9/6. 3 halves, 3 halves. Okay. If triangle DEF is similar to triangle GHI, the measure of angle G is 110 and measure of angle E is 25. What is the measure of angle F? So the first thing we want to do is draw the triangles. Okay, so let's draw them out. So we have, here's your triangle. Here's your triangle. Okay, DEF and GH. Again, we want to label it the same as the other one. Same order. This is D a little closer though. Okay. The measure of angle G is 110. Oops. It's still on there. How do we stop this? No. It just keeps going. There we go. Okay, so okay, G is 110. E is 25. What is the measure of angle F? So D and G are corresponding angles. Okay. We know in similar triangles, corresponding angles are congruent. So D and G are congruent, so D is going to be 110. Okay, and then what do we know the three angles of the triangle add up to? 180. Right? Triangle sum theorem. So we're going to have 110 plus 25 plus the measure of angle F is going to equal 180. 110 and 125 is going to give us 135. Okay, subtract 135. The measure of angle F is going to be 45. 45. Right, and those three are going to add up to 20. This would be 25, and this would be 40. All right, so last one for this part is 16. Given that triangle JHK and triangle POM are similar, We know the measure of angle H is 90, the measure of angle J is 40, the measure of angle M, or angle M, and angle O. The measure of angle M is x plus 5, the measure of angle O is 1/2 y. Find the values of x and y. I think that's what that's supposed to be, the measure of angle M and the measure of angle O. Okay, so let's draw them out. We have J, H, and K. Then we have P, O, M. Again, put them in the same order so you know what you're doing. Okay, so you have your corresponding angles lined up. So J and P are corresponding angles, H and O are corresponding angles, K and M are corresponding angles. Okay, the measure of angle H is 90 degrees. Wish this pen right in the middle. It doesn't go in the middle though. 90. J is 40. Okay, and then M is x plus 5. X plus 5. And O is 1/2 y. Okay. Well, let's find the measure of angle K. We know that the three angles of a triangle are going to add up to 180. So 180 minus 90 minus 40 is going to give us 50. Right? Three angles of a triangle have to add up to 180. Triangle sum theorem. Okay, corresponding angles of similar triangles are going to be congruent. So we know that 50 and x plus 5 are going to match up, right? We know angle K is congruent to angle M. Here's K, here's M, the third letter in each one. K and M are congruent. Therefore, the measure of angle K is going to equal the measure of angle M. Okay, therefore, 50 is going to equal x plus 5. Subtract 5, and we get 45 equals x. We also know H and O are congruent, so angle H is congruent to angle O. So the measure of angle H is going to equal the measure of angle O. So we know that 90 is going to equal 1/2 y. How do we get rid of the 1/2? We're going to multiply both sides by 2. We get 180 equals, the 2's cancel, and we get 180 equals. Okay. So we know corresponding angles of similar triangles are congruent. Therefore, the angle measures of corresponding angles are equal to each other. So K and M are equal. H and O are equal. We can solve for x and y. All right, so that will be part 1. 40 minutes about, so that's about what I expected. So I'll do part 2.